Alrighty, so in math, we use a variety of methods to represent a situation or a function or relation. The three main ones that we use the most often are tables, graphs, and equations, as you see here. They are all related in some way, and what's really important is that you understand how to move between the three and turn any of the forms into the other two. So let's just talk about tables and graphs for a second. These are probably the most basic forms that you're used to. Okay, when you have a table, usually it looks like a little T-chart with X and Y. You have numbers on either side written all the way down, right? Well, how does that relate to a graph, which we know looks like this with an X-axis and a Y-axis and a whole bunch of points, right? Well, a table is simply a list of coordinates, right? So how do we turn a table into a graph? You graph the coordinates. Pretty basic, right? All a table is a list of points. Okay, you just have to make sure you're graphing the X on the X-axis, Y on the Y-axis. So in the same way, how do we go backwards? How do you take a graph full of points and turn it into a table? Well, you just write the coordinates. This is probably the easiest relationship to see. Okay, so we get that relationship. How does a graph relate to an equation? That one's a little bit harder to see, okay? In fact, I probably would go the long way on this one. I would go from a graph up to a table and then take the table back down to the equation, right? We are going to learn a little bit more about how to turn a table into an equation, but I would say for right now, what you are used to is just looking at the numbers and just trying to state the relationship with an equation. This may not all fit. State relationship with equation. Okay, so for example, if you see a table that has 1, 3, 2, 4, 3, 5. Well, how am I going from the X to the Y? I'm just adding 2, adding 2, adding 2. So the Y's would equal the X's plus 2. Right? So we just took a table and turned it into an equation. So you're just stating the relationship using equation notation, right? Again, we'll learn a systematic way to do that later. Well, how do you take an equation and then turn it back into a table, right? So let's kind of give an example of that. If I have y equals 3x, well, that means in my table, no matter what x I have, let's say it's a 4. Well, I need to take that 4 and multiply it by 3 to get my y's. 4 times 3 is 12. Let's say I had a 7 in my table. Well, I put that 7 where the x is right here. 7 times 3 is 21. Okay? So again, to take an equation and turn it into a table, I'm just going to say that you plug in values. Okay? So I plug in a 4 and I get the 12. Plug in a 7, I get the 21. Okay? So now connecting a graph and an equation and vice versa. This is something that we really will learn more about this year and get a little bit more detail on. I would say for right now, to go between these two, to go from here to here and here to here, I would just take the long way for now. So for example, if you have a graph and you want an equation, well, you're going to write the coordinates, then you're going to analyze that table and then try to write the relationship and get to the equation. Okay? Same way if you start with an equation, I would make a table by plugging in values, and then I would graph those points on a graph. Okay? So really, until a little later in the year, we're not really going to talk about going from an equation to a graph and a graph to an equation, but you need to be really solid on these other 4 methods that we just wrote down. So let me give you a quick example of doing this in a situation. So we have this card here. Domino's Pizza charges $12.25 for a large pizza. In addition, they charge a delivery fee of $4.75 in any order. Create a table, graph, and equation to represent the cost of purchasing any number of pizzas. Well, we haven't been given a table, graph, or equation. We've been given a story. So it's kind of your choice where you start when you're given a story. I like to start with a table. I just think that that's the easiest. So before I do that, I need to figure out what are my two sides going to represent. What is the first variable? What is the second variable? Well, I've got a cost up there, and my cost depends on my pizzas. So I'm going to put pizzas here. I'm going to put the cost. Okay? So, for example, if I buy, well, I'm just going to do this. 0, 1, 2, 3, 4, 5. easiest to start with those. I would always start with 0, by the way, but I wouldn't necessarily compute 0 first. So let's read this. If I buy one pizza, it says it's $12.25, but I also have to pay that delivery fee of $4.75. That means total, that's $17. Okay? Well, what if I add another pizza to that? Well, that's $12.25 times 2. That's 2 pizzas. So that would be $24.50. But then I still have to pay that delivery fee plus $4.75. So that's what? $29.25? I may have to check my math here. I'm sorry if there's a typo in this. I'm going fast. Okay? If I have another pizza, well, instead of doing 3 times $12.25 plus $4.75, let's just add another $12.25 right here. Okay? Add another $12.25. This is kind of hard for me to do mentally. $41.50, right? Add another $12.25, and I get $53.75. Add another $12.25, and I get, what, $65? I think that's right. Okay. Now let's go backwards, right? In theory, if you call Domino's and you say, I don't want any pizzas, they would say, okay, and then you would hang up and it'd be over, right? But in the math world, we really need to consider mathematically what 0 would cost here. If you called Domino's and you said, I don't want a pizza, but I want you to drive out to my house, they would still charge you that $4.75 delivery fee, okay? And the reason we're going to include that is just for, you know, mathematical consistency here, right? To go between each one of these, we are always going to be adding $12.25 over and over and over and over. So that means to go backwards from 17 up to here, we need to subtract $12.25, okay? All right, so now I have a table. I need to do my equation and my graph. I can just take my points from this table and put them onto my graph. So I have a point here, 0, 4.75. So I start at 0, which is right here. I go to 4.75. That's approximately 5, so I'm going to put it right there. 1, 17. So I'm going to go over to 1. I go up to approximately 17. 2, 29.25. That's pretty much 30, maybe a little bit under. I'm going to keep going. 3, 41.50. It's a little bit high. 4, 53, 25, and 5, 65. Right on the money. All right. So you can see this makes sense, right? You can kind of tell that there's a constant rate of change here, constant growth with my pizzas. Okay, so I'm on my graph, on my table, so you need an equation. On the last slide, we said that the easiest way to do this right now is to look at your table, right? We've got a table. We're starting here, and we're trying to find our equation. So I'm looking at this outside arrow. State relationship with an equation. So I need to look at my table, think about how I can relate my x's to the y's. Well, I know 1 times 17 gives me 17, but 2 times 17 is not this, right? So it's not just a simple jump, okay? 1 plus 16 is 17, but 2 plus 16 is not this. So it's a little bit more complicated. Really, I would look more at my situation and the story to figure out the equation in this sense. So it's $12.25 for each pizza, right? Each implies that we need to multiply it, okay? But then I'm also adding on to that a delivery fee of $4.75, okay? So y equals, y being the cost, 1225x plus 475. I could test this out if I wanted to by taking one of my values from the table and trying it out. So for example, I know that 5 as an x should give me 65 as a y. If I put a 5 here and I multiply by 1225 and then add 475, I should get 65. And I know that we do. So again, that's just kind of a good representation of how you move between the 3 and really 4 in this case, because we have a situation and how everything is connected. If this is at all confusing, then I would suggest that maybe you come talk to me about tutoring a little bit. If you're having trouble converting between the 3, you're really going to struggle as we move forward in algebra. I would say every single thing we do from here on out involves looking at every single representation at the same time. We want to be able to be comfortable finding the slope, for example, from a table, a graph, and an equation. We want to be able to find the intercepts from a table, a graph, and an equation. You'll find that that is a common thread in what I ask you to do, that I will ask you to do something in all 3 forms. So let me know if you have any questions, and you have no homework to go along with this, so that's good.